So I am going to mix 25 mLs of 3 molar lead nitrate with 45 mLs of 2.5 molar potassium chloride. 3 questions we want to answer. Number 1, what is the final number of moles of potassium ion present? What is the final concentration of potassium ion? And what is the concentration of the excess ion at the end of the reaction? So here's a little visual description of what is going on. So these are your reactants, and this is the product. Here are the chemical reactions. You should keep in mind your solubility rules. So this would be lead nitrate is soluble in water. So we prepare this solution, lead 2 nitrate, right here, by dissolving it in water. So it dissociates into lead 2+ cations and 2 nitrate ions, anions. Similarly, potassium chloride is soluble in water, so this is the reaction. And it dissociates into potassium ions and chloride ions. Now, the reaction that we're concerned with here that's going to take place is the formation of solid lead chloride from the lead cations and from 1 lead cation and 2 chloride anions. This is the reaction here that's taking place. So it's also important to note that potassium and nitrate do not precipitate into anything. So when we look at this, when we want to know what the final moles of potassium ion present is, it doesn't react. Once it's dissolved, it's going to stay dissolved. It's not going to precipitate. So we're just going to calculate how much was present in the beginning. So that's 45 milliliters of potassium chloride stock. That's where I got this from. Times, and this is just a way of expressing 2.5 moles per liter. 2.50 moles of KCl per 1 liter stock. It's a proportion. Notice how my units are going to cancel out. Anything in the numerator is going to cancel out with the denominator. And that's how much moles of potassium ion are left. You want to find the concentration? Well, we're going to add the volumes. We're adding 25 mLs plus 45 mLs. And we're just going to divide the number of ions by that. And I'm going to express it in moles per liter molarity. So what's the excess ion? Well, we want to find out if we might have used more of one of the reactants, be it lead nitrate or potassium chloride, than we needed to. So I'm going to find out how much. I'm going to say, all right, I have my 25 mLs of lead nitrate stock. That's what we have in the problem up here. Let's just find out how much potassium chloride stock could react with that amount of lead nitrate. So again, we're forming proportions. So I'm starting with this. And 3.0, this is the molarity, 3.0 moles of lead nitrate per liter. And our units are going to cross out. So we have 0.075 moles of lead ion. How much stock is going to react? Well, we're just going to work through the stoichiometry. And we're going to find out that 60 mLs of stock could react. That's with the amount of lead nitrate we had. 60 mLs of potassium chloride stock, I should say. So potassium chloride is the limiting reactant. We only have been given 45 mLs of that. So there's going to be some lead nitrate left over, or lead ions left over, because the nitrate's a spectator ion. So let's see how much moles of lead is going to react. Same thing here. We're going to cross it out. Remember that 2 moles of chloride react with 1 mole of lead. 2 moles of chloride ion react with 1 mole of lead ion. So that's how much is going to react. This is how much we started with minus how much we're reacting. That's how much moles of lead ion left over. And if we want to calculate the concentration, we're just going to divide it by the volume, and that is our answer.